So then, so today we're a bit earlier than normal. Last week was really cramped, so let's. Yeah, it's still last week's slide as well. One bit we can cover. So lazy initialization. Sometimes you need something in an object or in a class, but you don't need it right now, or you want to have the ability to have this field, but you want to kind of wait with setting it until you need it. And that idea is called lazy initialization. So what you want to do is basically transparently wait for setting the value until you need it. Of course, in this particular case, it's not particularly useful because we know 42, but sometimes it's like, okay, I need this value, but actually when I calculate it, I need some other state that I don't have yet. Or to get this value, I need to hit the internet, download it from the internet, and then have the value, or hit a database. It takes a lot of effort. And if my object actually, if the users of my object actually never use that value, then I do all this work for nothing. So it's mostly only worth it when it's expensive. So what you can do is say, okay, we have a value that this is a way of implementing. So one of the values say it has not been set. You can use objects for that instead with null. There's even a way you can say, okay, you have a special one object that means it's not set. Well, if you have to have a null value, you might need to have an object that represents the null value or the unset value. And then you have a little bit more complexity in your code. But in this case, what we just do, okay, less than 0, we set it, and then we return the value. Kind of this is how you would do this. So in Kotlin, you would need to have a helper field for this. To use the underscore for it. And then when you use it, you just get the value like you would normally do it. So it's completely transparent from a usage side. But in Kotlin, this is actually not how you would often do this. Because there's a better way in Kotlin. Come back to this particular construct in a later lecture, but Kotlin has this idea called property delegates. You can create an object that the system will treat as a property. So you can create, so this function lazy creates a capital L lazy object that you can basically use the keyword, basically delegate this property to. So it will automatically pass the get to that object and the set to that object. So there's this lazy object that does all of that, what I said before, and more. Because this one is actually thread safe, whereas the other one is not safe. If you do it in multiple threads, you might have the situation where one thread already sets it to another value, and then it does get overwritten by the initializer because some other getter read the -1. So you can read the -1, other set comes in and does stuff and sets the value, and then the getter returns and sets the value back to 42 because that's the initialization. So lazy does all that correctly and more. And of course, this is much easier to read, much easier to understand. So you can use a property delegate to basically communicate your intent much better. But underwater, it's the same thing. So Kotlin has, for some of the patterns, has actually built-in support to make it easy to use these, because we know that they are common things to do, and they're hard enough to get right.